Before we fully engage into the topics within this course, it is important to fully understand some fundamental prerequisites of calculus so that we can be successful. Below are the 7 different preliminary topics we will be discussing over the next few videos that will be a guide in understanding calculus, and today we will be going over the first topic of polynomials. Now for starters, all algebraic expressions can be referred to as terms, with the simplest term being a standalone x. This x is known as a variable, which means that its true value is unknown or ever-changing. Add another x and we get 2x. The 2 in this case is known as a coefficient as it is a constant unchanging value. If we were to multiply by x, we would get 2x squared. The 2 here is known as an exponent or power value. All these ideas make up the basic idea of terms and expressions. Let's look at these two terms, 5m to the 4 and 2m to the 4. These are known as like terms, as they both share the same variable and exponent. This means that if I were to expand the coefficients like this, I could easily add or subtract them together because they share the same value. However, any terms that do not share the same variables or exponents are known as unlike terms, and they cannot be added or subtracted together. Now that we know what terms are, we can now get into polynomials. A polynomial is a finite sum of terms in which all variables have whole number exponents, with no variables appearing with denominators. These polynomials are ordered by the highest exponent that the expression has, with the lowest polynomial having an exponent equal to 0. This is known as the zero order or the constant, where the polynomial is equal to a constant number like 2 or 9. This is because any variable to the power of 0 will always be 1, so the coefficient of the term will be the term itself. The next order is known as the first order, which is linear or straight. This defines a polynomial with its highest exponent being 1. This often describes straight lines under a graph. Next, we have the second order, also known as quadratic functions. These are the most basic form of polynomial, which you will see in most of the course, expressed in this form. Finally, the fourth most important polynomial is the third order, in which the highest exponent is 3. These are known as cubic functions and define lines with 2 separate bends in them. Although there are more orders of polynomials in mathematics, these are the 4 most important types which you will need to understand as they make up the backbone of algebra. Note that the order of polynomials are only dependent on the highest exponent. That means that some polynomials can skip or even repeat certain exponents. Now, when it comes to operating on polynomials, it is important to understand each skill properly. It is also important to understand the order of operations when it comes to operating on multiple terms. This can be summarized as bracket, operation or exponent, multiplication, division, addition, and subtraction. You can watch my previous video for more details. Now there are 3 properties of real numbers that are pivotal to understand. Firstly, any value a plus or any value b must be equal to b plus a. This is a commutative property, indicating that the sum or difference of unlike terms can be written interchangeably on the same side. Secondly, any 2 values a and b added inside a bracket plus any value c can be treated in the same way as these 2 expressions. This is because the grouping of these values using parentheses or brackets does not change or alter the final value. This is the same case for values like this. Thirdly, any value a that multiplies a sum of 2 values b and c must be distributed between the 2 values in brackets like this. This is because a must multiply both b and c individually before adding each value together. Now that we know the basic properties of real numbers, it's time to learn how to add and subtract polynomials. Let's say we have these 2 polynomials and we wanted to add them together. What we must first do is combine the like terms together like this. Then we would simply add them, then rearrange them to get this. This concept is the same for subtraction. However, when subtracting, we must always remember to distribute the minus sign so that each value makes sense. When it comes to multiplying polynomials, we may need a little more intuition. First of all, we must understand that any variable m that is to the power of any positive integer n is equal to the product of m n many times. For example, x to the power of 3 is just x times x times x. Therefore, in the same way, 5x times x is simply 5 times x, which is 5x squared. If we had an equation like this, we must remember the distributive properties. 8x must multiply with both 6x and -4 before operating on it. This will therefore create this 48x squared minus 32x. When you cannot operate on a polynomial anymore, the expression is said to be simplified. What about if we were to multiply these expressions together? Once again, we will need to use distributive properties. What we need to understand is that each term within the expression is independent and must be multiplied with each other term. This means that 2m must multiply this expression in the same way that 7 must multiply this expression, giving us this format. Therefore, just as we previously did, we would just multiply out the values and simplify the expression to create this as our final result. Alternatively, we could use the FOIL method for solving these types of equations. This stands for first, outer, inner, then last. What about if we wanted to multiply multiple expressions together? Well, in the same way, we would first have to split the expression into two groups, then multiplying out the bigger group first, then using that value to multiply out the smaller group. Just as we saw in the associative properties, it doesn't matter which values you multiply first because the result will be the same. In terms of dividing polynomials, we will not get into much details of this now, as we will be discussing it later when we talk about integration. However, it is important to understand how to divide single terms with each other. Let's say we wanted to divide these two terms. To do so, we would need to understand that any values found in both the numerator and the denominator must be cancelled out, as when you divide a number by itself, it gives 1. Therefore, if we were to expand these terms to look like this, we would notice that 3b's in the denominator would cancel out 3b's in the numerator, giving us this expression. 15 divided by 3 is simply 3, giving a final answer of 3b.